Good evening, everyone. So, this is the fourth webinar which I'm taking. The first one being Introduction to CNC, second one being the M code and G code, the third one being the all the major things. Now, fourth topic. What is the fourth topic? Now we are going at this point. So we discussed about offset in the last class. The third one was being offsets. So this lab, what we are going to do is we are going to take a topic. This heading you can see it is machining operations beyond buttons and CNC screens. Why I have given that name? This title has been given intentionally because many people nowadays they know to operate the machine. They know to operate the machine. They know to press the buttons, which switch, all those things they know. But they don't know. They don't know what are the basics or what happens with the tool and the metal. And many people doesn't know. Many people they are aware, but they clearly don't know They clearly don't know about the operations, manual operations, or all the operations they don't. So we are going to discuss about those things in this session. So welcome to the session. Because once you know about these operations, you can do anything on the machine. So welcome to the session. Have a great evening. Now, what are we going to study? The end of session, you should be able to know what are the basic machining operations, and I'll be explaining it in a simple way, not in a very technical way or anything. I'll be explaining it in like it will be factory based or work based, but it will be in the simple terms. So nothing to worry attending this thing. Now, who is this session? So if you are a beginner, you can attend this session. And if you are diploma, ITI, fresh engineers, you can also attend this because maybe in your colleges, you might have learned this in the first years, but then you might have forgotten because this is a brush up for you guys. So anyone who is curious about the manufacturing also can attend this webinar. Now, what is machining? What do we mean by machining? So machining is nothing but it is removal of unwanted material. It is removal of unwanted material. So what we will do, we will start with the raw metal piece. This raw metal means it will have extra material in that. It's a raw material. It doesn't have any. It doesn't have any dimension, any shape. It is just like we are going to make that into a good product. So that is known as the raw material. Now, what will happen? Machining is a process where we will be carefully removing the extra material. The extra materials will be carefully removed by the process called machining. So what we will do, we may do drilling, milling, so all those things to get the required shape using special tools. So that is how we are going. That is what we are going to discuss here in this session. Okay. Now, operation versus machines. Operation versus machine. In the simplest possible words, if I tell, machining means removing unwanted material. I told you, right? Now, what are operations? Operations, we have different operations. Operations are what we do on a machine. What we do on a machine. What are things we do on a machine? We have many things like drilling. We have milling. We have lathe. Okay, lathe operations. So here you can see facing is an operation. Lathe is the machine. Okay, drilling is an operation. Milling is a machine. CNC is a machine. So what will happen? Operations is what we do, and machine is where we do. one prepares for the another. Now, machines will change. Machines will keep on updating. It will keep on updating. So earlier, in the earlier times, it was the manual machines. Then now we have the CNCs. Tomorrow, even now it started. Tomorrow we'll go to robotics. We can't tell what will happen, but the machining operations that never change. Machining operations never change. So what will happen? So if your the basic things are very weak, how much ever you know about the machine, that will be of not of much use. So basics is one of the main thing, because by knowing the basics, you can, and if you're strong at the basics, you can adapt to any machines. What are the, first we'll go with the hand operations. Hand operations. So what are the hand or fitting operations? You might have heard fitters. Okay. So what are the hand or fitter operations? They are manual operations done by hand by using, it's a foundation of machining. How they will do? They will use simple tools like we have files, hacksaws, chisels, punches, all these things. So what will happen? This, by using this hand coordination, or it's a perfect example of hand-mind coordination. So by these, doing these operations, these manual operations, what's going to happen? We are going to learn something called control. So what they will do, what these operations will do, they will teach something very important. That is how the metal behaves, how much force has to be applied, how a small correction will make a big difference. With the hand, you are going to adjust micron level things or a millimeter level things. So we will be learning more control of the machine and the product. Next, why do this hand operations still exist? Even today, after the CNC machines, when we have manufactured two parts, okay, how much of precision? Sometimes when we assemble together, during the assembly, some corrections might be required. Not sure it will be required, but it might be required. At those times, that correction will be done by the hand operations. Okay, that is why even today we have a tool room, we have a tool makers, all those things we have, because we need the hand operations or fitters, because we need for the final fitting, for the assembly correction, and for the maintenance work, we need the hand works. Now, so we'll go into one steps. First one, what is filing? Filing is nothing but we are removing the material using hand. We use a thing called file, which you can see in the images here. These files we can control. We can use it in controlled way to remove. If you want more material to be removed, we will use one type of file. If you want less material to be removed, we'll use another type of file. So we'll see about the filing first. So what are the types of files? So we have different types of files, in which the most commonly used is the bursted file, the second cut file, and the smooth file. You can see, if you see in the drawing in the side, you can see how that lines are coming. Those are the coarse lines, it's cross lines. So you can see bursted files will be having a little wider thing, and it's a little hard, and smoother will be closer, second will be more closer. So, and we also have this diamond files, all those things, right, for minute things. So filing is the basic thing. Even not only in the engineering, this filing you can see if you go to a dentist, for example. If you go to a dentist, even the dentist will have a very small type of file, which they will use to file the cavities in your mouth. So filing is the most basic thing, which is applicable to all the departments. Now, when coming to the shapes, we have different shapes, like We have the flat file, we have the round file, we have the half round file, we have the square file, triangle file. These are the types of files actually. You can see some designs in the image itself. Now, we are going to the types of filing. What are the types of filing? Types of filing is nothing but it is the how we file. We have the straight filing, we have the cross filing, and we have the draw filing. Draw filing normally is not done. It is used sometimes, very hardly. But straight filing is where we will be filing the product or we will remove the material by moving the file in the 90-degree angle against us. When we are standing, we will be taking it exactly 90 degrees. In the cross filing, it will be around 45 degrees, 60 degrees. We will turn it and we will file in the both sides, which will cover more area. Then, draw filing is just to remove the excess material. With the side of the file, we will do the draw filing also. So, most commonly used is the straight filing and the cross filing. Then, next thing is why filing is still important. Why filing is still important? Because in the factory, parts does not fit perfectly the first time. Sometimes, if the machine is not accurate or the machine has some issues or our programming has some issues, what will happen? This may not fit properly at the first time. So at this time, filing will be used to make small corrections so the parts fit smoothly and the assembly is proper. So the most important person in a tool room or in a workshop will be no one other than who knows filing very well. A person who can manually file and correct the program will be the most valuable employee in a workshop. Now next, after filing, I'm just understand one thing. We are just going through the very basics. I'm not going into deep things. We have more uses of this and more functions for this, but we are not going into that. We are just going to the basic things. Next, we are going to the hacksawing. What is hacksawing? Hacksawing is nothing but it's like cutting the piece. We are just using a knife and cutting the butter or bread or anything. Similarly, for cutting the metal, we will use the hacksawing. So how will be the hacksawing done? Normally the hacksawing procedure is we will be keeping the hacksaw in an angle and then we will be cutting it. So it is a manual cutting process and it is done before machining, and this also has to be precise because a change in dimension, if a mistake happens in hacksawing, that material will be waste and we cannot use that material for the current project. Next, we are going to the chiseling. What is chiseling? Chiseling is also removal of excess material, but here we use to remove where the machines cannot reach or find. If you have, for example, we have cut a profile and it has not cut out properly. At that time, to remove that product properly, that time we will use this chisel to remove the unwanted part, to remove the size. All these things will be also open a slot. All these things for fitting works we use the operation called chiseling. Then punching and marking. Punching and marking is where the machining really starts. What do you do? Because we are marking here where the work has to be done, where the hole has to be positioned, where the drilling has to be done, how the work has to. All these things will be done by using the marking. So it is just punching and marking is just like normally we looked up drawing, which is the 2D drawing. We are transferring the drawing to the material. The marking is but simply transferring the drawing onto the metal. So if the transferring is wrong or the marking is wrong, the material will be wrong, or the drilling will be wrong. Everything that for if it is a starting space, and first if this is wrong, all the balance, all that items just come behind also will be wrong. So you can understand one thing: machining never starts at the machine; it starts at the marking table. Okay. Now, next is a center punching. What is center punching? See, imagine you are drilling a hole. If there is no starting point, the drill will just keep on slipping. The drill will keep on slipping. So for that, what we will do is we will mark a starting point. This starting point is known. This starting point is marked by the center punch. We will use a thing called a center punch, which will create a small dent on the metal, so that our drill or whatever the tool will enter there. We'll have a starting point. We'll have a proper starting point for the area. Next, bench fitting and assembly. So what is there? This is just like we are doing the fitting, how to assemble the things. That is a basic thing. Bench fitting and assembly. There are multiple parts. For example, if you're taking a press tool, if a tool there is multiple plates, we have to assemble them properly. That is also a basic basic work which has to be done in the tool. Next, why we should look about the tools, why we should know about the tools. Tool awareness, this is very important. Why? The machines doesn't think. I am telling from the last class already. The first class I'm telling, the machine doesn't think of its own. Machine does not decide. Whatever tool or whatever instructions we give it to them, they work with that. So if we select the wrong tool, the machine does not know if it is wrong or right. Machine will directly use that tool and do whatever work you told. If a tool is wrong, the work will go wrong, and that means that you are getting a wrong result because we have given a wrong tool. So what happens? Only the tool decides the shape, and if the tool is wrong, the result is wrong. And sorry. That's why tool awareness is very important. Now we are going to the tools. Now we told about the operations. Now we are going to the tools. Now, what are the tools? First, let's let's talk about the single point and multi-point cutting tool. So as it is shown, some tools will have only a single point cutting tool, which if you have seen a lathe or somewhere, you could have seen that one tip will be there, and that tip will be removing the material. Such tools which have only a single cutting edge, it's mostly used in turning only. Cutting edge is known as a single point cutting tool, whereas we have multi-point cutting tools where we have multiple ends, multiple edges, and these edges will be very useful for removing the more material. Drills, end mills, reamers, all these things have multiple ending tools, multi-point tools, multiple ends, multiple tips. Okay, we'll say like 3 float, 2 float, 4 float, 1. These things are called as a multi-point cutting tools, and we'll come to some tools just now. Now, first thing, end mills. What are end mills? End mills are nothing but it is a tool for removing the material. So it's a tool that removes the material which we use in the CNC and also in the normal milling machines, conventional milling machines, conventional and non-conventional machines. We use these end mills to remove the material. So these end mills have different types. We have different types of end mills. We have the flat end mill, the bullnose end mill, we have the ball nose end mill, we have the chamfer end mill, and we have the engraving tool. So why these types of used? So when you want a flat, we will go for the flat end mill. We'll go into each and everything now quickly. Now, Flat end mill. As you can see in the image, it has a flat bottom. You can see here it has a flat bottom and it will have a sharp corner. The corner will be sharp, and why this is the most commonly used end mill, which gives flat bottom and the sharp corners. So if you want a proper flat surface with even a sharp corners and everything, we will go for the flat end mill. Next is the ball nose end mill. The ball nose end mill, as you can see in the image, the edge is like a ball. So where this will be used? We'll be using it for the curved surfaces or 3D profiles. When you want a curve or an arc or anything, we'll be using a ball nose end mill, which will give a smooth counter. They cannot make a sharp bottom corners. They'll give you a radial corner, just like it is given a fillet or something. It will be just like it will be a smooth corner. Smooth counters will be achieved by this thing. But if someone thinks that they can get a sharp corner with this ball nose, sorry, the ball nose is innocent. You have to use the end mill for it. Next is the bull nose end mill. So never get confused with ball nose and bull nose, because I know some earlier I have seen some employees who get students and employees who get confused between this ball nose and bull nose. So what is happening here? You can see it is similar to the end mill, flat end mill, but the difference is there will be a small radius in the tip of the end mill, maybe R1 or R.5, R2, depends on the customer requirement. What will happen here? This will have flat bottom but radius in the corner. This will improve the tool life a lot, and it will reduce the chipping. Chipping means removal of cutting of the edges. So you get a stronger corner and a better tool life. So that's about the end mills, basic end mills which we normally use. We have multiple tools, but we are not going to that. Then we'll go into the next is the drills. What are the drills? Types of drills. So there are different types of drill bits also. So drill bits, we have the twist drill, we have the center drill, and we also have the step drill. We have other drills also, but I'm just telling, I told you, I'm just going into the basics here. We are not going into much deep topics. So twist drill is the normal drill which we use with an angle of, always remember the angle of the drill, it will be 118 degrees unless we make it flat to make a counter bore. So twist drill is a normal drill with an angle of 118 degrees, which we use for normal drilling. A center drill is done. I told you we make a punch, center punch before making the drilling, and after center punching, we will use the center drill to mark that center. We'll just go 1 or 2 mm down, and then we will do the remaining drilling. And the step drill. The step drill is used for making sometimes a counter bore. Instead of counter bore, we can just use a step drill, or we can, in the sheet metals, we can use this based on the application. What is drilling? Drilling is nothing but it creates the hole, it removes the bulk material, and it is the hole operation. It's just making a hole. It does not give any accuracy. If the machine is wrong or the ovality is there, don't give the accuracy. It's not a finishing. It's just making a hole with the cutter which we give. Then, how drilling works? The drill will enter, a drill will rotate, it will go into the material, and these chips will come out. You can see in the image, the blue color, what the chips. Chips are nothing but the material which is getting removed through the flute of the flute is the way where the chips come. In the drill bit, you can see that spiral way. So the chip material will get removed like a chip or swirled chips, and will come out. If you understand that if the chips are not coming out properly, you have to understand that there is some mistake. Now, what are the limitations of drilling? See, drilling alone can't give you the exact dimension. Maybe the hole may slightly differ. It can become big, it can become small. That is normal. That is why after drilling we go for multiple other operations. What are the other operations? So what's happening? Drilling will set the foundation. Okay, we have drilled. From this drill we will do some other operations. Like for example, we want to make a exact size hole. Also we go for the other operations after drilling. So what are the other operations? We have drilling, we have boring, we have reaming, all the things we have. So what is drilling? I told you drilling is just like it's putting a new hole in the workpiece. Boring is nothing but it enlarges the existing hole. Not only that, see, boring is also used sometimes. At times what will happen is, by mistake the holes may be lightly shifted. At that time we will use the boring. It will be it is a single point cutting tool. It will have a low turning tool rotating speed. Spindle speed will be very low, RPM will be very low, and material removal rate will be very less. Okay, then when we come to reaming, what will happen? I think you all know about the fit, how a male part and a female part fits together. So if we want a clearance fit, if it has to move easily, we need a perfect fit. So for that perfect fit, for example, like H7 G6 fit. So these things we will use the reaming operation, where we will make a small hole first, then we will put the reamer and then give a perfect finishing to the hole. So as I told, boring operation is nothing but it enlarges the existing hole, then it improves the alignment, and we have more control on the drilling. So first we need a hole. We cannot directly do the boring. We need a hole and then we will do the boring. You can see in the image. Why boring is more accurate? Because boring is accurate because we can adjust the size. Then it's a single point cutting tool, and we get a better control of the tool. In the drilling, what will happen? The tool decides the size, but in boring, we decide the size. Okay. Where boring is used? So boring is used. The boring holes we will use for the accurate alignment, bigger diameter holes. Sometimes we may use a drill bit about 20 mm, but we need a hole of 50 mm or something. At those times, such a big holes we will be using the boring, where the bearing holes and everything, and the engines, pistons, everything, we will be doing the boring. Next is the reaming, as I told. So this is what we will do. Reaming is nothing but it's a finishing operation to improve the hole size and make the finish smooth. So what will happen here? What is happening in reaming? When we want to do, for example, a dia 8 mm dowel, if you want to put a dia 8 mm dowel, we have to use a 8H7 reamer first. So reamer, as you can see in the image, it's saying straight cutting pattern, straight flutes. So what will happen? We will drill always a 0.2 mm less. For example, for 8 mm, we will be drilling 7.8 mm hole, and then we will enter the reamer. We have to make sure one thing, hand reamer, or we are doing the hand reaming, we have the hand reamers and the machine reamers. So when we do the reamers, when we are doing the reaming, we have to always make sure we are turning it only in the one direction, clockwise direction. We are never going to reverse the rotation while putting inside or taking out. It will be going in the same direction, and we have to continuously use oil also, cutting oil also. So always remember, for reaming, for 8 mm reaming, we will be going to point to less 7.8 mm drill we will make, and then we will put the reamer, and we will turn it only in the single side. Next is the tapping. Tapping is nothing but we are doing the internal thread where we have to put the screws and everything. Okay, so what's happening here? This allows the tapping is used to join two pieces by using a screw to insert a screw. What is happening here also? We will use a smaller hole first. We have the formula 0.8D or 0.85D. By that, what we will do, for example, we are doing a M6 hole. If you're doing a M6 hole, we will be drilling of 0.8D. We'll make a hole of 4.8 or 5, and then we will do the tapping operation. In this tapping itself, there is a procedure. We will turn a little, come back. Again turn a little. We'll go clockwise for 2 rounds, turn back 1 round. Go counterclockwise 1 round, so that the chips come out easily. So we have this first tap, second tap, third tap. First we'll be using the first tap, then we will be using the second tap, and then we'll be using the third tap for the final tap. So you can see here what are the types of. So here you have the straight groove tap. Here spiral pointed tap. So this is like the third tap. This will be like the second tap, and first tap will be more conical. And then we have the spiral groove tap here, which is used to do the tapping. These are different types of tapping. Next, why this taps breaks? I don't know how much. When you work in the tool room, how many taps you will break. If you never broke a tap, that means that you have not worked properly on a tap. That's why the main issues are: one, the tap will not be exactly 90 degree, the clearance will not be enough, and the hole will be wrong, hole size will be wrong. For example, for I told you 4.8 required, we might have done only 4.5. Such things we will break the taps easily. Breaking the tap and removing it is very difficult. Now, what is a normal formula? So, basic tap drill formula is drill hole will be the nominal minus pitch. For example, you have a tap of M10 into 1.5, we will use 10 minus 1.5, which will be equal to 8.5. Just keep this in mind, or else you can put this formula 8. You can use this drill equal to nominal minus pitch formula, or you can also use 0.85 into D. D is the dia. For 10 mm, it will be 0.85 into 10 mm. You get a 8.5 answer. Understood? Next, how do we do the tapping? For tapping, we cannot do the tapping directly. First, we will be doing the drilling. Then we will give a small chamfer for the hole, and then we will tap. That is the normal procedure for tapping. Without chamfering, we cannot start it easily. We can, but it's not easy. Taps won't go straight 90 degree. We cannot align it properly. It's like we are not putting a key properly into a lock. How much precision we get in operation? So, in drilling, the base accuracy will be plus or minus 0.1, 100 microns. Boring, we get 50 microns. Reaming, we get 10 microns. And tapping, we get another 50 microns or over. Turning, we are going to some tools. Operations. Turning, what happens in a turn? Turning is nothing but we have the job rotates and the tool will be job will be rotating. We will move the tool in the feed direction and the materials will be removed easily. So what happens? It's for the round part, not only for round parts. We also use it for straight parts, where what we will do is we will always for facing, for removing if the material is more, thickness is more, and your milling machine is not free. What we will do is we will use it in the turning. We'll take it in the forge or chuck, clamp the square piece or rectangular piece, and we can remove material. Remove the material easily. Okay, that is why we use the turning operation. Next, we have the most common turning operations are straight turning, step turning, and taper turning. Straight turning is nothing but we are doing the straight. Step will be like we are giving into the steps. We are making steps and everything, And a tapper turning will be, we are making a tapper. We just, we are going in a conical shape or a tapper shape. That's how we will be taking the tapper. Then, just understand the purpose. Now, facing. Facing, it is used in both turning and milling for round objects and the straight objects. What this does, facing is nothing but it is for creating flat surface which controls the length or the height, and it creates a reference. In turning, the facing controls the length of the job. Without facing, what happens? The length accuracy is, and in milling, it controls the height of the job. It creates the top reference. It creates the it controls the depth. We get a reference properly. You can see in the images. You can see here. Here you can see it. This area will be faced, and on the milling, the top area will be faced. Milling. As I told, milling uses milling using a rotating cutter. In turning, is a rotating job and a fixed tool. Here, the cutter will be rotating and the job will be fixed. So, milling uses rotating cutter to remove material, and it can make any surface or shapes or slots or anything. That's the milling. No. What is slot milling? Slot milling is just like they are a keyways or guide slot. We are making a slot. We are making a way, a path, a shape. As per the drawing, we are making a slot. That's slot milling. Profile contour milling. What is profile milling? Profile milling is what? It is like we are giving the outer shapes or whatever design is there. We give the shapes in that. That is known as the profile or contour milling. I'm just going through the basics. We have lots of things. I'm just going through the basics and telling again and again. Next is the pocketing. Pocketing, as you can see in the image, it's like we are removing the internal cavity. We are making an internal cavity to make a flat bottom. It's like it's not a hole. It's not just a hole, because hole is always round. This may be of any shape. That's the difference between the hole and a pocketing. So pocketing means it's used for the functional. It's used for the functional cavities. Okay, it reduces the weight of the product also, and it is made to. We have to put other components inside. For those things, we'll be using the pocketing operation. So you can see here I have shown different types of milling here. What are these? See. This is known as the facing. Then we have a work. You can see the blue part is the work and the top part is the cutter. We can see different types of millings here: end milling, profile milling. We have the pocket milling. We have surface contouring. You can see for these types of, for this final one, for these types we use the ball nose cutters. For the last one we use the ball nose cutters. So first with a flat end mill, we will make a rough shape, and then with the ball nose, we will remove, we will be making this final shape. So pocketing is just, we are just making a cavity inside this, and profiling is, we are just going through the profile, we are making the profile with it. Okay, and then we have the slotting here, we make the slot when we're going inside and making a slot, and then this is the, we are removing the material from the top, and this is like, it's like face. Okay. Now, always keep in mind, the turning is for the round objects, milling is for the flat and shape objects, and pocket is for cavity. Remember that mistake. So, what we have discussed today? So, we did not talk about any machines. We're supposed to talk about CNCs, but we are not talking about CNCs. We talked only about the basic things. So we knew about the basic operations like filing. We knew what is drilling, what is boring, what is reaming, what is tapping. All those things we have seen. So if you have any doubt, please message me and I will be trying to reply for that. Okay. Any doubts? I'll be waiting for the 5 minutes. Please message me in the live chat if you have any doubts about this.